Hey everyone, and welcome to Atlas Insights, where we look at the customer service department within Trilogy Software and our AI-first approach to both customer service and automations in general. Okay, everybody, welcome back to the show. This week we have Balaji and Pablo, our two L2 bot experts, who have rolled out L2 bot to Atlas Ticket and Atlas Chat. Balaji is a fellow VP here in Central, and Pablo is one of our very skilled L3s. And I am very grateful for them trying to manage to get the time together, given that they live near enough on opposite sides of the planet. So one is very late in the evening and one is very early in the morning, but we'll let the audience pick, try and identify which one is which. But you're very welcome to today.
Yep. Hi. Hi
Thank
to
you very
you
much.
and your viewers.
Hi.
Cool, excellent. Okay, so I'm going to get out of the way as quickly as possible here. So Balaji, maybe you can start us off on an overview, how this came about, and we can go from there.
Yeah. So when we started building this, as we started the journey of Atlas, we were doing a lot of this task and the simple L1 tickets. But we realized that one of the challenges we need to, master is the ability to get into complex troubleshooting and support the L2 tickets, analyzing logs, and doing much more deeper analysis of tickets. And that's when we realized we need to build a system that can do think like an expert of the product will troubleshoot the ticket. And then we brought in a method. We already had few L2 bots already running. We had different variants going, and then we realized we also need to standardize the approach to troubleshooting. So that's when we came up with this innovative idea of building a troubleshooting strategy, just like how an expert will approach a ticket. We had two different ways of uh, a ticket comes in. One is through the chat, which is synchronous, where a customer interacts with the bot looking for solution to a problem. Second is a ticket, which is asynchronous, where an agent will work asynchronously. So both of it had its own different challenges of how an L2 will troubleshoot, or an L2 bot will um, approach solving it. Yeah, so here you see you have a ticket, which is basically an asynchronous way of solving a problem. Here our approach was to use three different endpoints that can um, first generate an action plan for the problem using the troubleshooting strategy an expert has already written for the product, which is basically a sheet with different components or different problems a customer can report based on our past data. So the first step is to use that strategy and generate an action plan and generate insights from it. Last step will be to, because it's an LLM, we also need to way to present that insights to the customer. So these three combined, the PR endpoint, insight generator, and action plan, is the async method when a ticket comes um, in our ticketing system. The other approach is the chat, where you have a synchronous conversation with the customer. We offer them a way to upload their logs, and then asynchronously process it while you're chatting with the customer. Okay, we're analyzing your logs and so on. So this is a high level overview of how we approach this problem.
Excellent. Cool. And you were saying we had many L2 bots before, like there are still 3 in production at the moment as we go live fully with Atlas L2, isn't that correct?
Yep. So we still have multiple variation, but this standardized approach, what it's trying to do is, the approach we are taking is the same when it goes to an L2 bot, but this innovation, what it's going to do is, you know, uh, standardize our approach to L2 troubleshooting, and our approach to going live with this also has been slower because it's a RAG, and you have this problem of hallucination, and sending answers to the customer which it should not send. So we have been little slower in our approach to standardizing it. We have first taken it live with 2 products, and then we are expanding it based on the results and review of what we have done. We have fine-tuned, and then um, st- um, that's the approach we're taking, so that we can have a standardized way of approaching this problem.
Yeah. No, it makes sense. And I mean, as well, it helps that, because we had 3 in the wild, we have 3 sets of data to compare and 3 different methodologies to compare. And we know as much what not to do as to what to do. So it makes perfect sense. And then I suppose it was kind of tasked on you, Pablo, to build the great. Well, you have one of the 3 L2s that was in existence prior to this was yours, and I think that's how you ended up being volunteered.
Correct. I was testing out some approaches to solving tickets as early as August and September of last year. Kind of learning the ropes, teaching myself some LLM, using LLMs in my Python code while I solve tickets to improve my performance as an agent. So I was kind of delving into that. And it sort of evolved out of that, that process where I was learning how to implement the LLMs into that L2 resolving. And then I figured, okay, so I need sometimes to know a bit about the product. The robot has to know some things about the product. So I need another companion system to the L2 bot, which I created for my L2 bot, which was the L1 bot, which is a basic RAG search over the knowledge base, but it evolved into something much more complex than that I can touch on in a little bit. And then it also evolved into, okay, so sometimes the L2 bot will need to read some logs, debug logs that the customer attaches or screenshots. So then I had to build another companion system to all of that, which I called the upload system. And the upload system is basically built on top of S3 in AWS, so that the customers can upload their logs or their files, and then an agent, an LLM would go over all those files and come up with some analysis, some reports, some summaries, and feed that onto the L2 bot. So that's kind of how it all started. It was from August to December of last year. I was toying with that for my tickets and some proof of concepts. And then in December, I started integrating it. I was volunteered to start integrating my solution with the then called Triage bot, which was another system was being developed by another team of people. I think Carlos was on the show already. So his bot was called the Triage bot back then, and it was a very a good marriage, right? So the Triage bot would sometimes send some things onto the L2 bot, so we started integrating that. And then Balaji started helping out and came in to lead the Atlas L2 implementation and standardization that he just mentioned, and applying the troubleshooting plan to it, like an infrastructure model to follow. So that also increased the accuracy of the L2 bot by a lot. And now we're starting to roll that out onto a bunch of products. I think 10 more products in this month, and it was being tested in 3 products in all of January. So with good results.
Cool. And I suppose in terms of, like, I think this is how you've structured having the L1, the L2, Maybe.
So,
yeah, go ahead.
No, you were going to ask me to explain this.
Pretty much,
very
yeah.
difficult chart. Okay, so this this chart attempts to illustrate how these systems interact and work together. Starting from a user query, which would be a ticket, a problem described in a ticket, that would, in parallel, first be sent to the L1 bot, which is an improved RAG system that will search the knowledge base for that particular product. It will create new queries, because that would, most of the times, the customer would not describe the issue exactly as we need it to be described to do a good search over the knowledge base. So we need to come up with ways to enhance the query and perhaps use LLMs to build new queries. So in this case, when the query comes in, there's a first LLM that uses a GPT 3.5 Turbo that will generate new queries, and then it will do some search over the knowledge bases, and it will combine and re-rank all the results from that search. It will also use the knowledge base to create what I call a product blurb, which is a basic description of the product. All those things go into the final prompt. So the final prompt is a big one that one of the modules is, you are an expert agent in this product. This product does this and that, and is used for this and that. So once we have the L1 RAG search complete, that goes in the background. And while that is being done, we also are augmenting and synthesizing the query for the L2 bot. So it's different types of searches that need to be done. The L2 bot is basically, like Balaji mentioned, it's a RAG over Zendesk tickets. So we have, each product has, some have 50,000 tickets, 100,000 tickets, 15,000 tickets in the past, prior customers that had probably similar issues reported, and agents solving the issues. So it's a RAG that looks in previous Zendesk tickets for the solution for the current issue. So it also has to interpret the query and build new queries. And that is used to search our Zendesk, our help desk system. It comes up with a bunch of tickets, probable tickets that could be useful for the final prompt. Then I chunk that and perform a search over those. And then the chunks are fed into the final prompt, which is also merged with the analysis from the upload system. At some point, every attachment on the query or on the Zendesk ticket will be sent to the upload system, which will be working in parallel with the Ask an L1 bot RAG and Ask an L2 RAG. And they all merge in the final prompt, which normally uses GPT-4 Turbo. It's a big prompt. So that was a godsend when the GPT-4 Turbo was released. I think it was November or December last year. Prior to that, the context was really small on the final prompt. There was, I think, a 3.5 Turbo 16,000 tokens back then available. But I feed a lot of things onto the final prompt. So as I mentioned, the product information, best ways to troubleshoot that product from the knowledge base itself, best ways to troubleshoot that product from the tickets, from the past tickets, from what agents did. If a ticket went to engineering, it went to everything that happened prior on a lot of tickets. The attachments, sometimes there are a lot of attachments on a ticket. It could be 10, 15, 20 attachments. So it's a long prompt. And that would produce a final answer. One thing that is not depicted there was a few additions that we did like the troubleshooting action plan that also goes into the prompt. I think there's another visual that shows that. At some point, we are doing some post RAG processing. Yeah, I think you can see the action plan generator, which is the component that Balaji added, and that is also fed into the final prompt. And also there's another LLM layer that calculates the confidence of the final PR, so it won't send updates to a customer that it believes are below 90% confident it will solve the original issue.
Cool. Yeah, it's like a QC step. And actually, from an optics perspective, the change we're making at the moment is to output that confidence score and the reasoning to the ticket so that somebody who comes after can actually go, okay, this is why they did or didn't send the solution. So it makes sense. Balaji, I suppose in terms of the action plan generator, do you maybe want to give an overview of how that came about and how we're doing it?
Yeah, so the one of the things as I started interacting with a lot of experts in central support, I realized is that actually as agents start working on tickets, it's like instantaneous how they solve the problem. Nobody really sits and thinks, how do I approach the problem? So there was not actually a well documented or well structured approach to solving an issue, because they are an expert. The moment they see a ticket, it's like they know where to look and what to look and stuff like that. So the the challenge was to first build a structure. What all should I use as inputs for the troubleshooting action plan. So when a ticket comes in, definitely I'm going to look for what are the different set of logs that I need or artifacts I need to troubleshoot this problem. Second is, what kind of component does it affect this problem. Third is, how do I approach the problem. So basically, the action plan generation use these three as inputs from an expert, and then it uses that and generates an action plan that will then be fed to the LLM along with the the query and the RAG data. So the combination, that's where the human element comes. The expert adding that the way to approach the problem, sort of like a guide, um, so that we are not going in a completely different direction to solve the problem.
Cool. Yeah. And so, yeah, we've tasked that to basically finding the best L2 or L3 agent that we have in the team and asking them to put that methodology on a document. And I don't envy them because, yeah, when it's something you do instinctively, it's very hard to document going, well, I just know,
Yeah, and the feedback I got was they even got some existential questions when writing those
yeah,
troubleshooting
they're
action
questioning
plan.
yeah. No, that makes sense. Yeah, that's it. I suppose as well, just something that popped into my head there as I was listening to the two of you in terms of to give context to people who maybe are outside of central support. Those two people who aren't in central support that watch this, but to give people the idea that in our tickets, we are very much based on documenting everything in the ticket. We have been since day one, because we know from having imported products and their tickets into our systems, it's not unusual to see in a Zendesk instance where the problem comes in and the answer is needful was done and ticket is closed, and there's no context of what had happened. So in Central, all of our tickets, there is not just what worked, but all the things that went before that didn't work, which is a blessing if you're writing a troubleshooting guide as to what to check. It's probably not such a good thing, Pablo, for someone who's reading in the L2 tickets, trying to decipher which part of the ticket solved it.
Yeah, I mean that's where the LLM is useful. In the beginning, the idea was that the L2 bot would be an L2 bot, leaving internal comments, useful internal comments for the next agents. And that's how we work. Usually when we solve tickets, we will look for prior instances manually and try to make sense out of a ticket. So yeah, like you mentioned, sometimes not everything is documented, but there's plenty of tickets to go about. Sometimes there are issues that are so common that have 5,000 tickets, and then you just have to pick the best ticket to look at. The good thing about the long context in these ones is that we can feed a lot of the chunks into the final prompt, re-rank them in the best way possible, and just feed them into the final chunk. And the LLM does a great job at interpreting those comments that happen on prior tickets in the context of all the other information that it has already on that prompt, like product information, best practices, how to troubleshoot logs for that product, debug logs for that product. So it will know. So it approaches a lot how a human would look at a ticket and study it and research and go to the knowledge base and then look at the log. So it has a lot of information sources to try to avoid that, and hopefully leave great documentations for the future bots and agents that will look at tickets.
Cool. And from a tech stack perspective, is it all Lambdas, or is there any server architecture? Or
in this case, it's built on Fargate servers. Most of it. It uses the systems use different technologies, but all built in AWS infrastructure. Uses S3 Fargate containers, Dockerized containers. No Lambda because the processing times of these things sometimes could reach the 15-minute limit of a Lambda. The API gateway that controls that sends the information, the request to the Lambda, also has I think a minute timeout that you can't control. So we use some custom Flask implementations over Fargate, and everything is on AWS.
Cool. Excellent.
And the other thing is the troubleshooting action plan is cached in a DynamoDB. So, that's for speeding up the troubleshooting action plan generation, because once it is generated, it's cached for future reference so that it's not generated again and again.
Cool. Yeah, it wouldn't be expected to be dynamic, I imagine. So, it makes sense for it to be there on repeat. Okay, very good. And I mean, I suppose we talk about time there. It does take, is it 10 to 12 minutes is the average time for an L2 ticket with this process, or?
Well, it depends on the ticket. I've seen tickets get a PR from SKL2 in 2 minutes, 3 minutes, 5 minutes. Some of them reached 10. Depends a lot on the context, on the type of information we feed it, and the different. If it has a lot of attachments, there are some safeguards built in to avoid timeouts. So sometimes when there are a lot of attachments, it will wait for a few minutes to gather all the attachments it can, but then it will continue if it didn't reach all the analysis of all the attachments. And we miss probably a little bit of context and a little bit of accuracy in the final answer. But that's another project we're working on, like measuring the accuracy depending. There's a lot of levers to tweak, like the prompting. Does it have 9 attachments or 12? Would that make the answer much better or not a lot? So those kind of automatic evaluation systems, we're also now doing some internal testing on how these bots are performing. but it can take some time. For the chat version, I'm not sure if Balaji, if you mentioned the async. I think you did. We have an asynchronous version for the chat that allows the chatbot to continue chatting with the customer while this is working in the background. And if it turns out the answer comes before the customer, before we give an answer to the customer, before the customer asks for an agent or asks for a ticket to be created, we can give that information to the customer. And if not, we just don't give it to him. So it's a seamless and invisible process that can go in the background as well. So it really, at the moment, the answer generation, we are trying to make it more efficient, but the way that it's built, it's much better than a human taking an hour or two. When a robot takes 5 to 7 minutes to give an answer, that's acceptable right now.
No, definitely. I think the only thing we found, and it is the reason we went async and chat, is just that emptiness. When you send something off for a complex process and everyone's there typing, going, "What's happening? Are you gone? Have you?" So I'm trying to remember. Did your DNN bot at one point tell a joke or tell an interesting fact or something while people were waiting?
Yeah, I have an LLM generating interesting facts, including reticulating splines from SimCity back then. I'm not sure if they like that, but I think it's funny and they get a laugh out of it while they wait.
No, I did. I remember seeing it in the transcripts and I was like, that's actually not bad. I mean, if someone's going to have to wait a few minutes, at least they know it hasn't, hung or whatever.
Yeah.
Cool. Excellent. Okay. And in terms of kind of the biggest hurdle to getting this far, the biggest tech issue or human issue or otherwise, what's been the toughest thing to surmount off the top of your head? Pablo first.
Okay. I think one of the tough things to surmount is the problem of hallucinations in the context of customer support. I know there's a lot of talk of hallucinations being a feature and not a bug of LLMs, and I agree that humans are creative, so robots that do human work should be creative. But in the context of customer support, sometimes battling with the bot giving hallucinated answers or mentioning a menu item that is not there, or completely making up a URL. That was one of the problems I had to deal with a few months ago, which the bot was making up the URL of the KB from the name and what the KB did. It linked the customer to a non-existent URL. So trying to cope with that and putting in some safeguards against that, and QC moments where it can know that it generated an hallucination and just discard that. That was a challenge, very challenging.
Cool.
Yeah,
I don't know, Balaji,
so the challenge I noticed was more on the how do I structure this troubleshooting action plan? This is the core of the idea, because we have products that are totally different, in terms of technology, in terms of the way they are used, and the domain they are used, whether they are on premise, on cloud. So really having a way, the initial design of it should be simple. At the same time, it should be really the way an expert would troubleshoot or approach the problem. So designing that was the initial challenge or hurdle that I found it challenging.
Cool. Yep. No, they're true, very valid. And I think, you know, these are problems we're finding in anything that we are deploying, you know, and God knows we're deploying
And
enough that we come across.
yeah, and
Cool.
another thing we also found that was this troubleshooting strategy that we are building is not just useful for the bot, can be useful for the humans as well. You know, it became another knowledge base for us because an expert is writing a troubleshooting strategy. So, you know, not everyone is an expert human working on the product. So it not just helped the bot, it has also helped knowledge of our agents working on the product. So, you know, unforeseen benefit um, we got out of this.
Yeah, no, definitely. I think, yeah, you can see it, as you said, the L2 who knows the product inside out just walks in and goes, I need to check this log, look here. And I'm 90% certain I found the issue. Somebody who's coming to it and this is their first time on the product, it is difficult to know where to look, because every product as well we have, they're so vastly different. You know, like if it's a firewall issue with logs versus if it's a telco issue where, you know, we might not have the same level or whatever makes sense. Okay, well, that's us just out of time today. I want to thank very much Balaji and Pablo for giving their time, especially at the, as I said, the differing time zones around. And we will see everybody in the next episode. Bye now.